Have you ever thrown a ball and wished it would just keep going, maybe even around the world? That's exactly what satellites, the space station, and even the moon are doing, falling, but never hitting the ground. The secret to orbit isn't flying up but falling sideways so fast you keep missing the Earth. Gravity pulls everything down, but with enough speed you can outsmart it. Imagine standing on a mountain so high it's above the air. Drop a rock, it falls. Throw it, it goes farther. Throw it fast enough and it could keep missing the ground, forever. That's what orbit is, not floating, but falling at just the right speed. The International Space Station, for example, is pulled by gravity almost as strongly as we are on Earth. So, why doesn't it crash? Because it's moving forward so quickly, it keeps missing the ground. Too slow, and you fall back. Too fast, and you escape Earth entirely. The perfect speed lets you fall around the planet, never landing. That's the mind-bending truth of how orbits work. You're not flying, you're falling, and always missing the ground. Let's go back to the 1600s with Isaac Newton and his famous thought experiment. He imagined a giant cannon on a mountain above the atmosphere, no air resistance. Fire the cannon gently, and the ball falls nearby. More gunpowder, and it goes farther. The faster you fire, the farther it travels before gravity pulls it down. But if you fire it fast enough, the ground curves away as quickly as the ball falls. Now, the cannonball is falling, but never getting closer to the ground. It's achieved orbit, a man-made moon circling Earth forever. This is the essence of every satellite launch. Throw something sideways so fast it keeps missing the planet. That's the ultimate throw, Newton's brilliant insight. It's not about escaping gravity, but using it to stay in motion. Every orbit is a perfect balance of speed and falling. That's how we put things in space. And it all started with a simple cannonball. So, how fast do you need to go to stay in orbit? For the International Space Station, it's about 28,000 kilometers per hour, 10 times faster than a rifle bullet. At that speed, you circle the Earth in just 90 minutes. Astronauts look weightless, not because there's no gravity, but because they're in free fall, falling at the same speed as their ship. The higher you go, the slower you need to orbit, but it takes more energy to get there. Geostationary satellites orbit at 35,786 kilometers up, moving slower but always above the same spot. Getting to orbit is a two-step challenge. First, go up, then go sideways. Fast. Most rocket fuel isn't for going up but for building that sideways speed. This maneuver, called the gravity turn, is what keeps satellites circling instead of falling back. It's pure physics in action. Every orbit is a dance between speed and gravity. That's how we stay in space. It's all about moving fast enough to keep missing the ground. Not all orbits are circles, most are ellipses. Fire Newton's cannon a bit too fast and you get an oval-shaped path. The closest point to Earth is periapsis, where the satellite moves fastest. The farthest point is apoapsis, where it moves slowest. It's like throwing a ball up, it slows at the top, then speeds up as it falls. Elliptical orbits are useful. A spy satellite might zip low over a target, then drift high to send data home. By shaping the orbit, engineers control where a satellite spends its time and how fast it moves. Every mission uses these principles to get the right view, at the right time. The ellipse is a cosmic tool for exploration. It's all about timing and trajectory. That's the power of the Galactic Ellipse. Is an orbit forever? Not at all. Rockets can change lanes in space. To move higher, fire your engines forward, speed up, and your path stretches into an ellipse. At the highest point, fire again to circularize your new orbit. It's a two-burn process, one to climb, one to stay. To drop lower, fire engines backwards, slow down, and gravity pulls you closer. A retrograde burn can even bring you home. Every maneuver, from docking to landing, is a careful orbital adjustment. It's not just flying, it's celestial mechanics. Every move is planned, timed, and executed with precision. That's how we explore space. Rockets are our cosmic vehicles, changing orbits as needed. If you want to keep exploring, subscribe and share. Let's get cosmic.